All right, welcome once again. By the way, I want to say thank you to everyone for checking in on me when I was sick in the past few days. Thank you very much. Um, like I said, I'm better now. So just to finish my medication and I'll be fine. All right, so the last time we met, we discussed the following. So I'm going to share you my screen. We discussed how to find the value of expressions using the properties of roots. So we did examples of this nature. So if you have, for instance, an equation whose roots are alpha and beta, and you are interested in evaluating the cube of alpha plus the cube of beta, which means the cube is sum of cubes of the roots without knowing what the roots are. These are the processes. Or you want to evaluate something like this, something in terms of alpha and beta, without knowing explicitly what alpha and beta are. That is what we use this idea for. Does everybody get that?
Yeah.
Okay, good.
Yep.
So that is one application. So I call that application 1 in your worksheet. So that is one application. So the second application is what we're going to be looking at today. How to form another equation, okay, from this equation. So for example, so I will give you a starter and I want you to do that within 3 minutes. So shall we go to the board, write today's date. I believe everybody see the board now. Today will be March 4th. It's a Wednesday. Okay, so just like the last one, we're still going to call it symmetric properties of roots. But the objective today is not to evaluate expression, but to form equation relating to alpha and beta. Okay, so we're still on symmetric properties of roots. So the objective here as a main objective. I give you a starter question. Let's take a mnemonic one so that we can easily check. To be negative. So if I try to get positive, so we can check easily. So the first question. need to say by solving the equation. So you should know it's by solving the equation. I believe we still remember how to find equation from given roots. Can you guys confirm that, please? Hello?
Yes.
So I want you to attempt this starter. I give you 5 minutes. Just be fast with it. Send me your question, your answers. Once you are done with question 1, send it to me on WeChat. Once you do question 2A, send it to me on WeChat. 2B, send it to me on WeChat like that. Okay? Can I add one more? Let's take the next 5 to 10 minutes to look at this.
Mr. Daniel, so if we're done with one, we just send like the first question
One by
first.
one, yes. Send it one after the other to my WeChat, not the group. Thank you, Melody. All right, good. Well done, Melody and Giselle. Got your work correct. Move on. Joey, work received. Wait, I need to check Melody and Giselle. Okay. Melody, you should check your work. I changed that equation to minus 6x. Melody, can you hear me? I changed it to minus 6x, not 6x.
Oh, okay.
All right, sorry about that. So it should be similar, just the difference in sign. Rita, I got your work. Please, can we send pictures not by turning our phone to the other side? I have to keep turning every time. Please. Rita, please take note of that. Okay, I think this is Justin. All right. Justin, where do you get alpha plus 1 cube or something like that? Oh, okay. Then you did alpha plus beta. Justin, can you hear me?
Yes.
So that shouldn't be alpha plus beta. That should be sum. Because alpha plus beta means 2 plus 4.
Oh, okay.
All right, so you should use the word sum. Let me try to find the class, the Zoom class for that day so that you can write it properly. Equation from given roots. So I'm going to share my screen with you now, Justin and everybody, of course. Check this. So if you're using this method, Justin, you should write it as sum. Can you see my screen?
Yes.
So because if you use alpha plus beta, you are referring to 2 plus 4. But remember, 2a is no longer, the roots are no longer alpha and beta. The roots are now alpha plus 1 and beta plus 1. So you should use the term sum of roots to add them. The answers are right, just the presentation. Well done.
Okay, thank you.
Hansen, I got your work. Hansen, your work is not acceptable. I don't want alpha is equal to 2 or 4, beta is equal to 4 or 2. Do the right thing and stop trying to impress me. I'm not impressed with that. Thank you. Melody, complete correction accepted. Denise, work received and accepted. Rita, I've seen the new one you sent.
Mr. Daniel, can you show the question?
Oh, okay, sorry about that. Who's that, Denise?
Yes.
All right, so here is it. Rita, can Rita hear me?
Yes.
Yes. All right, so you wrote the roots are alpha plus 1 and beta plus 1. Roots are 5 and 3. I believe you got your 5 and 3 by adding the other one. So I would say, now, number 1 gave you alpha is equal to, according to your solution, other people might be different, right? So when you are about to do question 2, your alpha plus 1 is 5, and your beta plus 1 is 3. I believe that's what you have done. So, so instead of saying x minus alpha, x minus beta, I believe this is the method you used. Yes? Now, Rita, hear me. So this method is acceptable. However, if you write this, you are referring to this same alpha and beta. Does that make sense? Because for this question, alpha and beta are not the roots. Alpha and beta are the root of this. So what you could do is to maybe use alpha 1, beta 1. So we know you are referring to the root 1 and root 2. This is not alpha 1, this is alpha. Do you understand that?
Okay.
Okay, so you can use this so to avoid unnecessary confusion. And I hope everybody understand what I just explained to both Justin and Rita.
Yes.
All right, so you can use that notation. If you are using Justin's method, instead of writing x squared minus alpha plus beta equals 0, Justin, you can make use of this also. You can use alpha 1, beta 1, alpha 1, beta 1. Or you could just simply say x squared minus sum of roots into x plus product of roots is equal to 0. So rather than working out alpha plus beta, you just work out sum of roots, okay? Because alpha and beta already represent something. They cannot represent two different things in the same question.
Mr. Daniel,
Yes, sir.
the alpha and beta in question 1 is the same as the alpha and beta in question 2, right?
That's the point, because the equation is 1. Look at the heading of the equation. Look at this side. Can you see?
Yeah.
So this is for both of them, isn't it? For both question 1 and 2, isn't it?
Yeah.
So from here, it's clearly stated alpha and beta are the roots of this equation, nothing more. So whenever it is used below this instruction, it can alpha and beta means the same thing all through. So that is why we need to be careful with notations. I've corrected my answer. So I guess Alex is going to send me a new one. For you, I got your message. First one accepted. Second, blah, blah, blah. So you just put alpha 1, beta 1, okay? Every other thing looks nice. And stop writing your arrow as if you're writing equals to 7. This is not an arrow. What's your problem? I've corrected that, and I hope that doesn't affect you. And your equation should have equals to 0 in every step. In every step. In every step. So you can't write, I saw x squared, no, x minus 5, just a sec. So we're going to be stopping this activity you're doing in the next 5 to 10 minutes because I need to explain the idea of today. So I can see from, this is only solution, so please take note of my observation. Right, so I'll tell you what is not appropriate. This doesn't look like the arrow. You're trying to use implies. That doesn't look like it. That looks like equals to 7. We don't need this because it's an equation. All you need is equal to 0 in each step. If you cannot use implies, please leave it blank. Don't put anything here. Am I making sense, mister? And also, this should be alpha 1, beta 1 because it's not the same as alpha and beta. Can you hear me?
Yes.
Good. Carter, in your factorization of question 1, I can't see equals to 0. You started with x squared minus 6x plus 8. I never gave you this. Then you did, after a few steps, you got x minus 4, x minus 2. And then I got x minus 4 is equal to 0, x minus 2 is equal to 0. Are you saying if I have 2 times 4, then you can say either 2 is equal to 0 or 4 is equal to 0? This is just evaluating. This is not an equation. So you have to always put your equals to 0. Don't be lazy to write, please.
Okay.
All right, I see the next picture. This must be Crystal. Crystal, I need to see x is equal to 4, x is equal to 2 first before you assign alpha and beta. Don't skip that step. Please confirm you heard me, Crystal.
Yes, I hear you.
Good. All right, good job. Alex, well done. I've seen all the correction. Everything looks okay. Is this Justin? Yeah, with his tiny writing.
Thank you.
You're welcome. All right, sum product is equal to 0, Justin. X squared minus sum bracket x plus product equals 0. It's an equation. Okay?
Okay.
All right. So Sonia, good. So Sonia, you do not have equals to 0. Sum of root x product of root equals to 0. Where is the equal to 0 part? Then you inserted the sum and product. I can't see where you actually work out the sum and the product. When we did the example the last time, okay, not in this class. I think that was the class after this. Where is it? Not here. No, not this one. Nature of roots. Must be the class before this one. Okay. Method 2. Look, can everybody see this? I had the sum and product done before putting in the equation. Can everybody see this? So please take notes. Shelley, I got your first one. Candy, this method is too complicated. Let me check the second one. This method of writing alpha plus 1 beta alpha 1 plus alpha 1 plus beta 1 x, then you change it to alpha plus 1 beta plus 1. No. All these complex calculations should be done outside the substitution. Candy, can you hear me? All this complexity should be done outside the substitution, please. Candy, did you hear that?
Yes, I'm changing it.
All right. You understand what I mean by the complexity, right?
Yes.
All right. Some people are just joining the class. I guess they are used to me reminding them. So there's a reason I didn't remind anybody today. I would tend to see how many people will join the class on time. Okay, so Rita, got all your work.
Can we go back to the question page?
All right, yes, sir.
Thank you.
Yeah. Okay, guys, we are going to stop now. Mr. Hiron Man, your last picture, final step is not acceptable. Why did you stop there? Since when do we write x squared minus 5 over 2x plus 1? Since when?
Was I supposed to make it irregular?
What do you mean irregular?
No, am I supposed to make a mixed fraction?
No. Okay, so let's see how this can be done. So, okay, Joey, you sent your picture earlier. I'm sorry, I'm just looking at it. What is it with you guys writing x squared minus 5 over 2x plus 1? Really? I saw that also in Joey's solution. Do I have to tell you to do what are you supposed to do? Can anybody remind me? Apparently, some people don't know what to do, and that is disappointing.
You have to times x by 2 to get rid of the fraction, and also times 1 by 2.
And you should get what instead?
2x squared minus 5x plus 2 equals 0.
Thank you. And did someone remember? Come on. Some of this attitude, I see it as nonchalant. It's like, well, it's made the same thing. I don't have to worry. Well, not on my watch. So the guys times without number. Nobody needs to tell you to get to do something at the right time. Anyway, that will be all we can take for your class activity. So for this starter, I've seen so many things that you have done. So basically, this is my expectation. I'll just maybe take one of them. So are we ready? So for question 1, maybe we can trying to minimize this space. So we can put everything on one page. So for question 1, I expect you to solve like we always do. So by factorization, I intentionally chose this. So it is easier. And many of you did. So x is 2 or x is 4. So in my case, alpha is 2 and beta is 4. Yours might be 4, 2. And there should be no or in this case. So for 2a, alpha plus 1 would be 2 plus 1, which is 3. Beta plus 1 will be 4 plus 1, which is 5. So 2 ways I can do it. X minus alpha 1, x minus beta 1, because I don't want them mistaken for alpha and beta. In this case, this is my alpha 1, and this is my beta 1. Okay, so that would be x minus 3, x minus 5 equals 0. That will be x squared. Eventually, you get this. For those that use the other method, so after identifying this, another method aside this one, I mean, so which means after identifying your alpha 1 and beta 1, then you can do sum of roots. If you don't want to call it sum, you could call it alpha 1 plus beta 1. Okay, so it will be 3 plus 5, which is equal to 8. Then product, if you do not want to call it product, call it alpha 1 times beta 1, which is 3 times 5, 15. I want this identified. So you write your equation as x squared minus sum. X, you don't have to write sum of roots. You can write sum and product like that. Or if you do not want to, if you have taken this step, then you should write x squared minus alpha 1 plus beta 1, x plus alpha 1 beta 1 equals 0. Then you substitute and you get 8x plus 15 as expected. So either way is fine. And the same thing you do for this. In this case, your alpha 1 beta 1 will be that. Okay. And here also your alpha 1. So I'm just going to give a sketch idea for B. My alpha squared will be 2 squared because alpha is that. And my beta squared will be 4 squared, which is 16. So this could be seen as my alpha 1, this could be seen as my beta 1 in this case. Then you follow the same procedure. Okay. For C, I have alpha over beta, which is 2 over 4, which is 1 over 2. So this is my alpha 1. I have my beta over alpha, which is 4 over 2, which is 2. So this could be seen as my beta 1. Of course, you don't have to label it. If you are not using alpha 1, beta 1, you don't have to label it. So if I want to do it this way, actually, I could write from the beginning, my beta 1 is this, okay? I could just write it at the end. Just write it at the end, and you have labeled this answer as your beta 1. Okay? So with this, you can find the sum. So I use the sum product approach. I prefer that to alpha 1, beta 1, actually. Sum is alpha over beta, no. Because you already have it as 1 over 2 and that, so sum is just 1 over 2 plus 2, which is 5 over 2. Product is 1 over 2 times 2, which is 1. So I write my formula as x squared minus sum plus product equals to 0, must be included. So x squared minus half x, now 5 over 2x. X squared minus 5 over 2x plus 1 equals to 0. Then you clear the fraction. 2x squared minus 5x plus 2 equals to 0. So given alpha and beta as the root of this equation, this is the equation with these roots, and this is the equation with the first one. Does this make sense, everybody? Talk to me, please.
Yes, it makes sense.
Yeah, makes sense.
All right. So, but we don't want to, again, just like the last application, we don't want to have to solve for alpha and beta to be able to get this equation. We don't want to know what alpha and beta are. This is easier because of what? Can somebody tell me why, one reason why this is easier to do? And when do you expect complicated? Yes, it doesn't what?
involve roots.
It doesn't involve roots. Is that Giselle?
No, it's Joey.
Joey. Okay, it doesn't involve roots, and it will have been more complicated if we have a bunch of fractions, isn't it?
Yes.
Right? But
Yeah.
it will be less complicated than the root, definitely, but it will be more complicated than these cases. Especially if you, now this is alpha over beta. Imagine root divided by root, then it becomes something. But if you're having the situation of maybe alpha squared beta and maybe beta, alpha beta squared, then, or maybe alpha over beta plus 1, and the other root is maybe beta over alpha plus 1, then it becomes more complicated, isn't it? So in that case, we get alpha and beta first, then substitute like we did, and get the equation properly, then becomes a big deal. So how do we do it without that? We'll do the same question again in the appropriate way. This is the appropriate approach. So going back to that question, alpha and beta are the root of that. So alpha and beta, I don't have to write alpha and beta at the root, we know that. So the equation is x squared minus 6x plus 8 equals to 0. Again, a is equal to 1, b equals to -6, and c equals 8, just like the last one. If alpha and beta are the root of this equation, we know how to find our alpha plus beta and our alpha beta. What is alpha plus beta, everyone?
Nine, 1 plus 8.
Where
Oh,
does
sorry.
that come from?
Negative b divided by a.
Thank you very much. And what is alpha beta?
C divided by
C
A.
over A.
Thank you. Now, alpha plus beta is -6 divided by 1, which is 6. Alpha beta is 8 over 1, which is 8. Understood? So we don't want to know what alpha and beta are, but we know alpha plus beta, we know alpha beta. With this, we can solve all the problems. So 2a, we're concerned about 2, not 1 now, because 2 is how the kind of question we want to go to. 2a, we want to find the equation whose roots are, the roots we want to deal with now are alpha plus 1 and beta plus 1. So all you have to do is sum. Okay, sum of the roots. If we need to find an equation, we only need to use x squared minus sum of roots into x plus product is equal to 0. All right, so all we need to find is the sum and the product, that's all. So the sum is going to be that, which is collecting like terms. Am I right? So which is going to be alpha plus beta is 6 plus 2, and this is 8. Then the product, alpha plus 1 times beta plus 1. And this will be alpha squared. No, alpha beta actually, plus alpha plus beta plus 1, which is already collected like terms, right? Alpha beta is 8, alpha plus beta is 6, then plus 1, and this is 15. And this is exactly what we got here. This method, can you see? Yes?
Yes.
Please, I don't want silence. Some ladies have been quiet. You know, I don't like that. Please respond. Thank you. So this is already what you have. So you can proceed by saying the equation is I'm introducing the word new because we already have an equation here. So the new equation is x squared minus sum times x plus product is equal to 0. State this all the time. So that implies this is what OU is trying to do. So this implies, that is, this means, that's what it's trying to say. This means that, okay? Or this implies that, but you don't write it as equals to 7, as not implies. If you don't know how to write it, then don't write it. Minus 8x plus 15 equals to 0. And that's how we do it. Okay? That's how we do it. Look at, I'm going to go to C, or maybe we just solve the A, B, and C. Let's just solve everything. I still have about 18 minutes to my meeting. So let's go to B. For B, what are the roots? So I'm going to copy the roots, alpha squared and beta squared. Then I get a sum of these roots, and I get a product of this root. I work out the sum first. Sum is alpha squared plus beta squared. Can someone remind me what to do? Class, I'm waiting, please.
Alpha plus beta all squared minus 2 alpha beta.
Good. So we use the property. We use the symmetric property. So this is alpha plus beta all squared minus 2 alpha beta. Because we have learned how to find alpha square and beta square without finding what is alpha and what is beta, by only knowing what is the sum alpha plus beta and what is the product alpha beta. I believe everybody remember this. Can I get a response?
Yes.
Yes.
This is 6 squared minus 2 times 8. 6 squared is 36, 2 times 8 is 16, so this is 20. The product, alpha squared, beta squared. What do we do now? What do we do?
Yeah, you
Bracket
factorize.
alpha, beta, and then squared.
Bracket factorize, well done. So that is 8 squared, which is 16. So again, the new equation is
Mr. Daniel, I
Mr. Daniel,
think you made a mistake
it
in the
should
last
be
line.
64.
my bad. Maybe I didn't get enough sleep. So that's x squared. Thank you. Plus products. X squared minus sum x plus product equals 0. And that implies, so again, I use the implication statement. This implies that x squared minus 20x plus 64 equals 0. Was that what we got earlier? Oh, we never did B. Is that what you guys did? Is that what you got?
Yeah, that's what I got.
Good. So let's look at C. For C, I believe everybody can see the screen and nothing is obstructing. All right, so C alpha over beta, beta over alpha. So the roots, in this case, alpha over beta, beta over alpha. Okay, write it as and beta over alpha. I just need something instead of going to the other page, yeah? I'm not asking you to write this all the time because it's already in the question. So you just go straight to the sum. Okay, so you should begin with sum. So sum here is alpha over beta plus beta over alpha. What do I do? Talk to me, guys. What do I do?
Make
You
it into
make
one
it
fraction.
into one fraction.
Yeah, so how do we do that?
In times.
Common denominator.
That would do what?
Alpha
Alpha
square.
beta.
Oh, what?
Alpha beta is the common denominator.
Oh, sorry.
One denominator, let's take it one step at a time. Alpha beta, yeah? So what will be the numerator here?
It will be alpha square.
Thank you. And here will be
Beta square.
well done. So now, as a single fraction is now alpha squared plus beta squared divided by alpha beta, yeah? Numerator or denominator, which one looks okay for now?
Denominator.
Now your numerator is alpha squared plus beta squared. And how do we do that?
We use the
Use
properties.
We use
Is
the
it called
properties.
symmetric properties?
Now you can use this. Can you see that?
Yes.
Because you are still dealing with the same alpha and beta. You are still under the same problem. Okay? You are still going to make use of this and this, isn't it? And since this has already been solved in part of the question, all you have to do is bring it in. That is 20. And alpha beta is 8. So all I need to do is say from 2a. Can you see that? So anybody grading my book, I'm telling them where I got that from. So I don't have to work it out again. I can simplify 5 divided by 2. Product. Alpha over beta times beta over alpha. What do we do with this? Hello?
Just multiply alpha beta over alpha beta.
And what is that? What do we do with that?
1.
1. You don't. Do we need to substitute x over 8?
No.
A
No.
waste of time. Yeah. So even directly from here, you know, you can cancel diagonally, right?
Yeah,
Right?
yes.
So you can just write 1 from here. So the new equation is x squared minus sum bracket x plus product, and that implies x squared minus 5 over 2x plus 1. Then I multiply by 2. Is everything okay? Is everything okay?
Yes.
Yes.
Everything's fine, yeah.
What?
Everything's fine.
Nobody notices anything?
Oh, you didn't put
Equal to
Close to
0.
zero.
0.
Equation yet, unless you have this. Equation yet. Okay? So this is what we need to do. All right? So this is what we need to do. So I'll show you something now. I prepared this last week. As a matter of fact, if you look at the dates, can you see the dates? I put the date of March 2nd because I was going to give you work to do and ask you to turn it in today. But due to my illness, so we will have to postpone that. This will have to be next because I want us to practice. I'll give you some to practice, not graded work, just so yourself practice. And then we'll get like maybe homework or something on Friday. There'll be no homework today, but you could just practice on your own. So let's play around. How about we attempt question 7? It's not one of my intended questions. So let's look at question 7 here. Okay. Alpha and beta are the root of this equation. Find the equation in X, whose roots are this. So I'm just going to make you take maybe question 7C. All right. Question 7C. Then I'll probably send you the rest of the question because I need to go to meeting in about 9 minutes. So let's go back to the board. All right. So the question says, if alpha and beta are the roots of. So now that's the end of the previous question. So when dealing with alpha and alpha beta, we have no business anymore. All right. So the alpha and beta are not the same. So I just say further example. If alpha and beta are the roots of the equation 3x squared plus 2x plus 7. find the quadratic equation in X. In X means the answer should be X squared minus something X plus something, right? If I say in Y, it means you should have something like that. Does that make sense?
Yes.
That's the purpose of the in X. So normally, if in X is not indicated, of course, X is mostly what we use. So, okay, so find the correct equation in X whose roots are, so question A, have alpha squared plus beta squared, 3 alpha plus 1. All right, so A is alpha squared and beta squared. B is 3 alpha plus 1 and 3 beta plus 1. Question C, alpha plus 1 over beta and beta plus 1 over alpha. And D, 1 over alpha plus 1 over beta plus 1. So you will notice symmetry all the time, right? You notice symmetry all the time. Okay, so like we did in the previous one, so again, we have the roots, okay? We don't have to go through the steps here. We have the roots. I won't be taking everything since the class ends in 5 minutes. Can you guys choose which one you want me to do, C or D?
Can we do D?
Is the first to respond, so we go to D. So these are the roots. All you have to do is sum. You don't have to copy the root again, like I did in this case. All right, you don't have to copy the roots like I did here. Here, okay? Just go to sum. Sum is 1 over alpha plus 1 and 1 over beta plus 1. We try to make this same denominator. Do we agree that we have beta plus 1 here and alpha plus 1 here? Good. So again, oh, sorry, before I begin, actually, before I do any A, B, C, or D question, I missed something. What was I supposed to do?
You need to find alpha plus beta and alpha beta.
Thank you very much. So, my bad. So that should have been the first thing, please. So before any of this, okay, so I say solution, which means my answer begins here. For the solution, I need to identify my A, B, C. A is 3, B is 2, and C is 7. Then I need to find my alpha plus beta, and I need to write it as negative B over A, which is minus 2 over 3. I need to find my alpha beta, which is C over A, which will be 7 over 3. That's the first thing you need to do. And you do not write it as mixed fraction. Nobody cares about mixed fraction here. Because we don't need them, we only need them to evaluate something. Outside this, then after this, then you may start your A, B, C, D. So now we're starting with D. Then we can find the sum, okay? And the sum is 1 over alpha plus 1 plus 1 over beta plus 1. Then, just like we did earlier, the LCM is this two. Numerator will be beta plus 1 plus alpha plus 1. To save time, we're going to expand the denominator and just rearrange the numerator. So this is alpha beta plus alpha plus beta plus 1. Then we substitute alpha plus beta. Here we have Negative 2 over 3 plus 2. Someone get ready with the result of this using your calculator. So this is 7 over 3. This is negative 2 over 3. And this is 1. What is the result of the first one here? 4 over 3, I guess.
4 over 3.
Thank
Yeah.
you. And this will be, this is 7 over 3 minus 2 over 3 definitely, which is 5 over 3. Is that 8 over 3? Please confirm.
Yes.
Yes.
So if I
Yes.
don't have a calculator, all I need to do is write them side by side first. Then I will turn it around and I'll be getting 1 over 2. And if you have a calculator, substitute directly, but please show some of the steps. I expect to see this, I expect to see this, I expect to do this, and of course this last one. You don't have to show this if you can use your calculator directly. So, product. Now we have found our sum. Product will be 1 over alpha plus 1. I think the product is easier than the sum. You don't have to use brackets. This already is a group. It groups them together. Okay, that groups them together. So, which means it's going to be 1 divided by alpha plus 1. This step is not important. I'm just showing us clearly. So you can move from here to this one. But bracket makes it easier to see the expansion. I believe everybody knows what I'm doing here. What I've done here is alpha times beta, then alpha times 1. And what I've done next is to do 1 times this, then 1 times 1. So that's what I've done. Should anyone have questions? So we can substitute. So that will be 1 all over alpha beta is 7 over 3 plus negative 2 over 3 plus 1. That would be 1 over, this looks like the denominator here. So I'm just going to say 8 over 3, and that would be 3 over 8. Please confirm. Waiting for confirmation.
Yeah.
Yes, it's right.
Yes.
Please, I don't want to ask twice. This has to, there should be some kind of flow, two-way communication, please. So that will be x squared minus, our sum is 1 over 2. Our product is 3 over 8. We multiply through by what this time? We multiply through by what this time?
Would it be 8?
8 because
So that would be 8x squared minus 4x plus 3 equals 0. And this is the end. Any questions?
So
no, I don't have any question.
No, I don't have questions.
Mr. Elson, can you tell me why you joined the class about 3 minutes before, 5 minutes before the end?
There was a little bit of miscommunication.
Can you speak louder, please?
There's a little bit of miscommunication, and I read your text on WeChat, and I thought it was tomorrow.
When did I say tomorrow? On WeChat.
It says, message me privately if you have any concerns, which I didn't. Sorry about that. And he says, thanks again. See you in class on Thursday.
I said we will resume what? Then we will resume our normal classes by when? It's clearly stated on WeChat, Elson. I'm looking at the message right now. Can you see your WeChat?
The message before I say, I hope you get well soon.
Oh, I said thanks again and see you in class on Thursday. Well,
yeah. Sorry.
That should be a typographical error because at the beginning, I'd already stated the day that I need to be off. In light of this, I'll be taking Monday and Tuesday off from all classes. Can you see that? And I already stated that we'll resume on Wednesday. Clearly stated. So if I've written a Thursday and you need some clarification, everybody should know that is a typo. And if you need clarification, you should have informed me since Monday. And I already posted on the module since 10 o'clock. So that should also, you should get a notification that, okay, the class begins today. I only needed Monday and Tuesday to recover. You don't have an excuse. And I hope Kelly is not going to come and tell me the same thing, as well as those that came in late. Anyway, guys, so I'll probably just put some questions. They are not like, how do I say? They are not graded question. They're just practice, all right, if anybody needs to. So Friday, basically, we will look at more of this. We'll practice during the class. I'll give you tasks in the class, or maybe just practice in the lesson. And after that, I will post homework for you that will be due next week. Okay, so we'll do that on Friday. Then we'll look at some other interesting questions on Friday. I'll show you some of them because we need to go like now. Someone is trying to send me a message, no question. Cecilia, speak to the mic. If I hardly use a message because I have to keep going back and forth from what I'm doing and trying to bring up the chat. So if you have a mic, please use a mic. Thank you. I hardly look at messages during these classes. Cecilia, can you hear me? All right. So on next week, next class, sorry, before miscommunication thing comes up again, we'll be looking at this kind of problems. For example, two roots of equation differ. Let me see, differ. Okay, look at this. The difference, find the value of k if the difference between roots is this. So we'll be looking at the questions of this form, and I'm going to try to find more of this. The equation differ by something, or one equation is the square of the other. Let me see the order. Not in this one, that's weird. Okay, anyway, we'll be looking at question of that form. I will be trying to prove something, but perhaps I put it in the first, just a sec, please. I hope I haven't put it in the first worksheet. Aha, I might have. So look at this. We'll be looking at how to solve this question, or has anyone been able to try it? This one, these last three questions. So I'm going to be putting them into that worksheet again. Can everybody see this?
Yes.
So we'll be playing around this kind of question and see how the symmetric properties of roots can help in solving these problems. All right. So if there are no questions, I'll see you on Friday. In the next few hours, I'll be posting some practice questions on the module. It's not graded. You don't have to turn anything in. It's just for you to, if anybody needs access to questions like this, of questions in like this one, it's just for you to, basically these first few questions that are not in the graded task, all right? Those are the ones I'll be putting. Okay, see you, bye. Thank you so much again.
Bye.
Bye-bye.
Thank you.
Have fun.